Okay, so we reviewed the metric system and conversions, and we reviewed graphing. So we're going to go ahead and talk about distance and displacement. So while you watch this video, I want you to try to come up with a definition of distance in your own words, and come up with a definition of displacement in your own words. And go ahead and write that down on your paper. Also, see if you can draw an example of each of those.
In this video, we're going to discuss the difference between distance and displacement. Let's go to the left. We're following a path. It's leading us to some destination. We're traveling a distance. We can measure this with different tools, with the trees, and curve there. And eventually, hopefully, find our path again. Yeah, there it is. We'll reach a destination. We've traveled a distance from our origin to the destination. We can measure that distance marked in red. Now, we'd like to go on a straight line path, of course. There's a mountain in the way. We'll probably do something about that. Alright, this works. Now we're going to be able to travel a displacement. A displacement starts at the same origin, but it travels in a straight line from an origin to our destination. This is usually much, much shorter. And there is our destination. We travel with a displacement marked in green versus a distance marked in red.
Okay, so let's go ahead and talk about our distance. Distance is going to be the length of a path between 2 points, okay? So the SI unit, or the metric unit, is meters, right? That's the base unit. So if you're going to be measuring something really, really big, like driving distances, you're going to use kilometers. If you're talking about small distances, you're going to measure that in centimeters. If you're talking about super duper tiny distances, maybe millimeters. Just remember, 1,000 meters is a kilometer, and 1 meter is 100 centimeters. If we want to measure a distance, you could take a look at a roller coaster, and you could measure the distance from the beginning to the end, right? Okay, so now let's talk about our displacement. So that is going to be the direction from the starting point and the length of a straight line from that starting point to the end point. And in that video, they called the starting point the origin. We use this when we're giving directions. We might say, go 15 blocks north. So that's the direction. And then 15 blocks is how far. So if we talk about a roller coaster, for example, the direction from the starting point to the car and the length of the straight line from the starting point to the car. So after you complete your ride, your displacement would be 0, right? Because you end up exactly where you started. Here's another example. If you look at this path, so you start right here. So you start right here and you end up right here. You can see the arrow representing the path. And if you wanted to measure the distance, you would measure that whole blue arrow. And if you wanted to measure the displacement, you would measure that green arrow. Okay? Okay, let's talk about vectors really fast. Vectors, it's a quantity that has a magnitude and a direction. And the word magnitude just means size, length, or an amount, a number, in other words. Okay. It's represented by an arrow on a graph or a map or a picture. You're going to see these in geometry. If you haven't taken it yet, or if you're taking it now, you'll see these. The length of the arrow, it determines how big it is, or the magnitude of it. Displacement, and that's why we're mentioning this now, displacement is an example of a vector. Okay. So let's talk about combining displacements really fast. So if we have two displacements, they're going to be represented by two vectors or two arrows. If they're going in the same direction, you're going to add the magnitude, add the numbers together. So for example, I have if this is 2 units large and this is 4 units large and they're going the same directions, then it would just be 6 total. If we have 2 displacements that are represented by 2 vectors or 2 arrows, and they're going in opposite directions, then you're going to subtract those numbers. So if I have this one that's 2 units, this one that's 4 units, but they're going in opposite directions, you would subtract those, and it would be going 2 in that direction. Okay, because this one's bigger, so it'd be going that way. So let's just take a look at what that would look like with real numbers, because it's kind of hard to look like when you're looking at it abstractly. So here's vector addition. So I have 2 different cars. This one's going 4 kilometers, and this one's going 2 kilometers, and they're both going to the right? So if I'm adding them up, we would have 4 kilometers plus 2 kilometers. So that'd be 6 kilometers. And in what direction is what you're looking at and that would be east. Okay. So let's look at that if they're going in different directions. So we have 4 kilometers plus 2 kilometers, but the one going this way is bigger, so you would subtract them. So we have 4 minus 2. So it's 2, but the one going east is bigger, so that's why it has an east there. Okay. So let's do some more sample problems. So you need to see if they're going in the same directions or different to figure out whether you add or subtract those numbers. So the first one, same direction, so 10 going to the right. So different directions, right? So they would cancel out. So next one, we have same direction, right? So you just add them up. So 15 going to the right. Next one, they're going different directions. This one is bigger, so you would subtract, and then 5 going that way to the left. Okay, they're going different directions again. So it's 10, right? And then it to the left because that one's bigger. Okay, and the last one, again, they're different directions. So we subtract, so it's 5, and then this one's bigger, so going that way. So it's probably pretty easy for you. So we're going to put our geometry skills to the test. Okay, so you have either had geometry or you're in geometry for most of you. So let's see. Take a look at this little picture and see if you can figure out what geometry skill would you think you should be using. Okay, so if you said, before we get started, of course, displacement is a straight line from the start to finish, right? We just said that. So if this is our path and we ended up here, so displacement is from here to here. So that's what we're trying to figure out, okay? So what skill can we use to solve this problem? Well, we just made a right triangle, right? So that's your hint. We just made a right triangle. So we're going to use the Pythagorean theorem to solve this problem. So Pythagorean theorem is a squared plus b squared equals c squared. So a squared plus b squared equals c squared. So it doesn't matter what you call a, what you call b, but I'm calling this a and this b. So I'm saying 5 squared plus 10 squared equals c squared. So let's do that math. So 5 squared is 25. That's a 5. And 10 squared is 100. Equals c squared. So that's 125 equals c squared. Okay. So then to solve for c squared. So that's not our answer, right? 125 equals c squared. So what is c? Well, you have to square root them. So the square root of 125 is... Okay, so the square root of 125, and I just did that on my calculator, is... is 11. Okay, so c equals 11. And our directions on that would be northwest. Okay. Okay, so let's try one more just to make sure that we got it. So here's our Pythagorean theorem, and so remember that we want to try to figure out the resultant vector. So we have a path that's going 30 kilometers west and 40 kilometers south. Okay, so if this is where we started and this is where we end up, here is our displacement. Okay. So here's our right triangle. Okay. So it doesn't matter what we call A and what we call B. So I'm just going to call this A and this B. So I'm going to say 30 squared plus 40 squared equals C squared. Okay. And I can't do these guys in my head, okay? So I'm going to get my calculator out. Okay. Okay. So 30 squared, I guess I could do them in my head, but 30 squared is 900 and 40 squared is 1600. So, okay, I could do them in my head, but that's okay. Okay, so we add those together, so we can do that in our head. 2500, that is C squared. So that's not our answer, right? We have to square root it. And we probably could do that in our head, but if we can't, we can use our calculator, and that is 50. So this is 50, and our direction. So our direction would be southwest.